Calculate the integral from 0 to 1 of the inverse tangent of x dx. Let u equal the inverse tangent of x and dv equal dx. Therefore, du equals dx over 1 plus x squared, and v is equal to x. Then formula 6 gives the integral from 0 to 1 of the inverse tangent of x dx equals x times the inverse tangent of x on the interval from 0 to 1 minus the integral of from 0 to 1 of x over 1 plus x squared dx. And that equals 1 times the inverse tangent of 1 minus 0 times the inverse tangent of 0 minus the integral from 0 to 1 of x over 1 plus x squared dx. And because the inverse tangent of 1 is equal to pi over 4, we have pi over 4 minus the integral from 0 to 1 of 1 over 1 plus x squared dx. To evaluate this integral, we use the substitution t equals 1 plus x squared, since u has another meaning in this example. Then dt equals 2x dx, so x dx equals 1 half dt. When x equals 0, t equals 1. When x equals 1, t equals 2. So the integral from 0 to 1 of x over 1 plus x squared dx equals 1 half the integral from 1 to 2 of dt over t minus 1 half the natural log of t on the interval from 1 to 2 equals 1 half open the natural log of 2 minus the natural log of 1 close equals 1 half the natural log of 2. Therefore, the integral from 0 to 1 of the inverse tangent of x dx equals pi over 4 minus the integral from 0 to 1 of x over 1 plus x squared dx, which equals pi over 4 minus the natural log of 2 over 2.